Section 3. Evidence for quantum consciousness? But, asked Koch, is there any evidence for such quantum mechanical effects in biological systems? And he replies that, until recently, the answer was a resounding no. In 2010, the prestigious journal Nature published measurements of quantum mechanical electronic coherence within a photosynthetic protein at room temperatures. But it remains to be seen whether coherency plays a role in the core operations of the brain itself. There is no evidence, for now at least, of any of the molecular components of the nervous system, a warm and wet tissue strongly coupled to its environment, display quantum entanglement. In addition, Koch points out that, in general, biophysics conspires against stable quantum entanglement. Two operations underlie information processing by neurons: the chemical transmission of information from one neuron to another at the synapses, and the generation of action potentials. Each operation would destroy coherent quantum states because both operations involve either hundreds of transmitter molecules diffusing across the synaptic cleft, or hundreds of ionic protein channels that are spread along the neuron's membrane, changing their configuration. Neurons firing action potentials can only receive and send classical, not quantum information. That is, at each moment, a neuron either generates a binary pulse or it does not. Thus, a neuron is never in superposition. It does not both fire and not fire action potentials at the same time. Hodgson refers to a similar objection, namely that since brain cells are macro objects and their firings are macro events, quantum indeterminacies are irrelevant to their operation. He also offers a possible answer, i.e., that indeterminism at the microscale can be magnified so as to create indeterminism at the macro scale. However, Hodgson also quotes the physicist Paul Davies to the effect that this would only impair the functioning of the brain. Davies says, "The idea that mind finds its expression in the world by courtesy of the quantum uncertainty principle is not really taken very seriously, not least because the electrical activity of the brain seems to be more robust than that. After all, if brain cells operate at the quantum level, the entire network is vulnerable to random maverick quantum fluctuations by any one of myriads of electrons." In terms of dual aspect monism, however, this dismissal, like many others, can be criticized because it takes an excessively reductive materialist approach, ruling out a conscious aspect a priori. Koch goes on to refer to the work of Karl Popper and John Eccles. He first establishes that they were both highly distinguished in their respective fields of philosophy and neurophysiology. Nevertheless, they claim that the conscious mind imposes its will onto the brain by manipulating the way neurons communicate with each other in the regions of the cortex concerned with the planning of movements. By promoting synaptic traffic between neurons over here and preventing it over there, the mind imposes its will on the material world. But Koch dismisses this theory because it requires the mind to force the brain to carry out some physical action. Like a poltergeist, the mind must rumble and tug synapses. That is work, and work costs energy. Even the minute expenditures of energy needed to tweak synaptic transmission have to show up on nature's balance sheet. Physics doesn't allow any exceptions. The principle of energy conservation has been tested again and again and always comes out a winner. If the mind is truly ephemeral, ineffable, like a ghost or a spirit, it can't interact with the physical universe. It can't be seen, heard, or felt. And it certainly can't make your brain do anything. The only real possibility for libertarian-style free choice is for the mind to realize one quantum mechanical event rather than another, as dictated by Schrödinger's equation. On the other hand, Koch's assumption that the mind is truly ephemeral, ineffable, like a ghost or a spirit, is just another example of the hegemony of folk psychology. Koch further comments that even if the Popper-Eccles mind could, under our current quantum interpretation, exercise a choice between superposed possibilities, it would be powerless to change the probabilities. In other words, the mind could decide what happens on any one trial, but considering many trials, nothing out of the ordinary would take place, only what is expected from natural law. Conscious will would act in the world within the straitjacket of physics. It would be indistinguishable from chance. Koch insists that this would be the maximal freedom afforded to the conscious mind. In a choice balanced on a razor's edge, a tiny shove one way or another could make a difference. But if one outcome is vastly more likely than the other, the whispering of the conscious mind is too inconsequential to fight the odds. Koch concludes that lay people and mystics alike have had an inordinate fondness for the hypothesis that the weirdness of quantum mechanics must somehow be responsible for consciousness. But even if we accept that entanglement is somehow critical to consciousness, how does entanglement explain any one specific aspect of the mind-body problem? How does it explain the transformation of excitable brain matter into phenomenal experience? In his 1949 book, The Concept of Mind, Gilbert Ryle suggested, and even more emphatically, that quantum physics had nothing to do with human freedom and responsibility. The modern interpretation of natural law as statements not of necessities, but of very, very long odds, is sometimes acclaimed as providing a desiderated element of non-rigorousness in nature. Now, at last, it is sometimes felt we can be scientific while reserving just a very few occasions in which appraisal concepts can be properly applied. This silly view assumes that an action could not merit favorable or unfavorable criticism unless it were an exception to scientific generalizations. With the help of Whitehead, Stapp, Hodgson, and others, we will attempt to answer these questions in later units. John Taylor revisits the Copenhagen School's claim that consciousness collapses the wave function. He points out that no one has any idea as to how this might work, but appeals to the ironic achievement of solving the two mysteries of quantum and consciousness in one go. However, he's very clear that there is absolutely no evidence for a quantum basis of consciousness. The uncertainty brought about in chemical transmission across a synapse by quantum mechanical effects can be calculated to be less than 1 in a million of non-quantum effects. They are therefore negligible. A further range of suggestions as to how quantum mechanical effects may in fact be of relevance to consciousness was surveyed, but they have no specific relation to the creation of particular states of mind, especially consciousness. Consciousness has a different character from that which could be supported by quantum effects. The latter are expected to involve coherence of activity over localized regions that are in a suitable state. Such states are known in quantum mechanics only as long as they are at a very low temperature. This cannot be the case for regions of the brain involved in the firing of nerve cells. Quantum mechanics, on the other hand, indicates that consciousness in the brain is correlated with inactive regions, not active ones. This is clearly seen to be false from the fact that particular regions of the brain are known to be active in humans who have the corresponding conscious experience and no defects. Loss of these regions leads to the loss of the corresponding conscious experience.